All right, so we have a couple more complicated problems here. So here's the first one. Sorry about that 2 being there. It should not impact things. It says in triangle X, Y, Z, angle Y is 90 degrees. Uh-oh, right angle alert. And angle X is 70. Angle ZWY is 76 and XW is 70. Find the length of WY to the nearest 100th. Nearest 100th. Okay, I don't understand why they're doing it like that, but that's fine. Okay, so when we're doing this problem here, all right, if we have a 90-degree angle, we have a right triangle. So this is a right triangle. WY is my unknown. Let's call that, we'll just leave it as the unknown. We'll call it WY in the problem. So eventually I want to use this right triangle to find WY. But the problem is I need another something in this right triangle. Well, there's a lot of information here. I have a 70-degree angle. I have a 70 side length XW. So what if I look at this non-right triangle first? Maybe I could find this shared side, right? Isn't this the shared side, ZW? Wouldn't that help me in this right triangle? It would. So let's go ahead and try to find ZW. Let's make that our first unknown. Well, I do have an angle measure, and I have a side length. I can get another angle measure right there. I can find this angle because they form a linear pair. So to find this angle right here, angle XWZ, take 180 and subtract 76. That's 104. This angle is 104 degrees. And now I have another angle. This is the angle side angle case. I can find side ZW. Okay. Now, right now, I don't have an angle opposite side pair, right? This 70 side length is opposite of this angle Z at the top. But I can find that angle, right? Now that I know this is 104, I can take 180 minus 70 minus 104. That's going to be 180 minus 174. That's 6 degrees. This angle right there is 6 degrees. And now I can use, and again, I'm sorry, my colors are really blended. I can use 6 degrees and the side 70, and I can use 70 degrees and my missing side ZW to find ZW to use in this right triangle to then find my question mark WY. So this is a two-step, multi-step problem. So sine of 6 degrees over its opposite side of 70 equals sine of 70 degrees over its opposite side of WZ. So WZ sine of 6 degrees equals 70 sine of 70. And we'll divide by the sine of 6 degrees. Type this in my calculator, and that's going to give me what WZ is. So I'll use the graphing calculator. Hopefully all that stays there. Let's double check to make sure. Yes, good. So if I go into Desmos, again, make sure you are in degree mode, and we are. So I didn't take a picture, sorry. Here. So 70 sine of 70 over sine of 6. So 70 sine of 70 divided by the sine of 6. And we got 629.2877. Don't round too early. Don't. Okay? So I'm going to come right to here, and I'm going to cut it off at 7. I'm going to make this 7 round this up to an 8. So 629.288. That's what I'm going to say that side is. That seems really long, but this was 70. It seems like very long, though. So this side is 629.7 or 678. Terrible at this. 629.288. So sorry about that. I got 3 kids. That's my excuse. So that's this side right here. So now in this right triangle, I have 76 degrees. So what 2 sides do I know? Well, I don't know the opposite, but I now know the hypotenuse. It's 629. And I want to find the adjacent. Hypotenuse and adjacent, that is cosine. Cosine of 76 degrees equals adjacent, our unknown WY, over the hypotenuse, which we just found out to be 629.2 uh, 0.288. 0.288. Yeah. We're going to multiply both sides by the 629.288. And now I'll just type this in my calculator. 629.288 cosine of 76 degrees. Make sure I'm in degrees. I am. 629.288 cosine of 76 degrees. And I got a length of 152.238. It says round to the nearest hundredth, so that 8 makes that 3 become a 4. 152.24, and that's going to be the length of my missing side. 152.24. Cross your fingers. Again, my rounding, I hope it doesn't mess me up. No, check mark, yes. Look at that. And again, notice their work, right? Find the missing angle, use the law of sines. And again, they use the law of sines again, wrong. Don't follow this. This is a right triangle. Use right triangle trig then. Okay, that's more than you have to do. Okay, second type of problem coming. Okay, so here's this problem looking. So now we have a triangle XYZ. Angle X is 21 degrees, angle Y is 68 degrees. Angle XWZ is 90, so there's 90-degree angles here, and XY is 42. Find the length of XW to the nearest integer. So that's no decimals, right? So if you look here, this is what I'm looking for. There's my question mark. It's in this right triangle. So eventually I'm going to use this right triangle right here. So I need to find a side in this right triangle. Well, notice the 42 goes in the big triangle, so we're going to use the big triangle as well to start. And notice that the big triangle and this right triangle share XZ. Let's find XZ first. And then we'll use XZ in this right triangle to find my mystery side. Well, I have 21 degrees in the big triangle, I have 68 degrees in the big triangle, and I have 42. So I will use 68 degrees to find my mystery side, but I need the angle opposite of 42. That's this angle right here. Well, in the big triangle, I have two of the three angles, 21 and 68. 21 and 68 is 89. 180 divided by 89 is 91 degrees. Minus 89 is 91 degrees. This angle right here is a 91-degree angle. And now I can use it and the 42 in the law of sines, because what is this situation? Angle, side, angle. Okay, so sine of 91 over the side I know of 42 equals sine of, and I'm going to use the 68 because I want to find its opposite side, xz. Xz sine of 91 degrees equals 42 sine of 68 degrees. Divide by the sine of 91 degrees. XZ equals, and I'm going to type this in my graphing calculator, 42 sine of 68 divided by sine of 91. Okay. So let me go into graphing calculator. I'm going to assume it's still in degrees. I'm going to hope it is. I didn't touch it. Did you? So we have 42 sine of 68 degrees divided by the sine of 91 degrees. And I got a side length of 38.9476. Let's go ahead and round this to 38.948. 38.948. And that's going to be that side that is shared in both the small right triangle and the big triangle. 38.948. So that is now this side right here. 38.948. So in this triangle, here's my angle. I don't know the opposite side. I do know the hypotenuse now. I just found it, and I want to find the adjacent. So again, adjacent hypotenuse, this is again a cosine problem, ka, right? So ka toa. So cosine of 21 degrees equals my adjacent side, which is xw, over my hypotenuse, which is 38.948. 38.948. Let me just double check that 38.948 again. Yep, 38.948. I will multiply both sides by 38.948 to get 38.948 cosine of 21 degrees equals xw. And that's when you need to type in 38.948 cosine of 21 degrees. Let me do that right here. 38.948 cosine of 21 degrees. And I get 36.361. I think it said round to the nearest integer. So that 3 leaves the 6 a 6. 36 would be the length of that missing side. Fingers. Oh, yeah, nice work. Okay. Cool. So I like this problem because it does involve right triangle trig as well as your non-right triangle trig. Okay, so hopefully these made sense. They're not easy. If you have questions, let me know. All right. One more video coming from Edulastic covering some word problems.